All right, so we are moving on to chapter 9. So we're moving on from triangles, trig ratios. We're not going to forget them, though, because it's a big part of what's going to be on your final. I think I had 1 or 2 more people who still needed to finish the test, but as soon as those are done, I will have them graded and posted. Sorry that they're not posted already. If you want to come over, or if you want to come down to my office hours and go over your grades when you see them posted, if I haven't passed them back yet, please come do that. But as of right now, we will probably not finish chapter 9 before spring break, and that's the end of the quarter. So we will likely only have 1 quiz before the end of the quarter instead of a quiz and a test. If we can fit it in, I might, because I'd rather we end at spring break and not have to go a whole week before you guys test on material. So if we can get it fit in, I will try, but if not, then you have 1 quiz left. So that means if you're not happy with your grade, you need to start coming and retaking things as soon as possible, okay?
Wait,
yes.
Have midterms again?
You don't have midterms. Nope. Just finals at the end of the year, but not at quarter 3. But the final will be the whole
After
May. The last 4 days of school. Okay, so you have a while, but quarter 4 goes by very, very quickly. Every year it goes by very quickly. And we do very little new material. We're going to do probably a chapter and a half. Yeah, because you end up it just goes by quick. Yeah. Yeah, it's the same as it was before. So you'll have 1 test and then a break and then another test and then you'll go home. And I think you guys, it's probably going to be like last time where you have 1 day where you only have 1 test. But I don't know. They haven't done a schedule or anything, but I think you guys only take 5 finals. How many midterms did you have? 5?
Yeah.
Yeah? Because you had 1 day where you were done, where you only had 1 test, right? So I assume it'll be the same. Yeah. What? No, because they all of you take 1 math class. So you do go to work. Yeah. It's your last day of work. And you guys actually, it's the Wednesday, the last Friday is a Wednesday, Friday also. So you guys. Mm-hmm.
Then you don't get out early.
You just got a new job. I can tell. All right. What'd you say?
Oh, finals are the whole.
It's the last week, yeah. But you'll work that Wednesday. So it'll be, I want to say it's I think Memorial Day is a little earlier this year. So I think it's the Monday, Tuesday, and then you'll work Wednesday and then Thursday, Friday. But it depends. I still am waiting to hear if we have to do a weather makeup day. Do you know anything?
No.
I thought we did Easter Monday, but then I've heard that we're not going to because it's Easter Monday, but I don't know. All right. Okay. I think we're sufficiently distracted. Let's get started. So we are going to move on to start talking about the stuff that you probably thought when you started geometry, the stuff that you probably had done before and thought about before, is what we're going to move on to right now. So typically when you thought about geometry, what did you guys think we would be doing? Shapes. Finding the what? Area, perimeter, that kind of stuff. We're going to be doing a lot of that, and we're going to move from 2-dimensional shapes into 3-dimensional shapes. So we're going to be doing area, perimeter, and volume for the next unit. So today we're going to start talking about different irregular polygons and how we would find the areas of them, and then how to determine formulas that we can use to find the area of various polygons. So the first postulate we're going to talk about is the area of a region, the area addition postulate, which says the area of a region is equal to the sum of the areas of its non-overlapping parts. So what does that mean? The area of a region is equal to the sum of the area of its non-overlapping parts. Look at this shape up here. What is it? It's a hexagon, right? Is it a regular hexagon? No, because most hexagons look kind of almost like a stop sign, right? But not quite because it doesn't have enough sides. So how would you find the area of this? What are you doing there? Tell me what you're doing, Angel. No, what were you pointing at? You're gonna use the 6 at some point, right? Because that's the length of this figure. Okay, and then Gabe, what did you say? What do you mean by separate it?
Separate, to make 2 squares
Okay, to make this into shapes that we know, we can cut it in pieces. So where would we want to cut this one? Well, would you want to cut it like this? Why? We need rectangles, or we need shapes that we know. This is 2 trapezoids, and I don't really feel like finding the area of that because that's harder to do, right? So let's find the area of 2 rectangles. So I can cut this in 2 different places. Where could I cut this? Miguel? Like right here? Where else? Or down this way? Which one do you want me to do? The top one? Okay, so right here. So now I have 2 rectangles, right? Imagine that I actually drew that perfectly where it was supposed to be. So imagine those are 2 perfect rectangles. So now we just have to find the area of both of them. But how are we going to do that? Because this little rectangle up here, what do I know about it? Nothing? I know something. I know 2. What is 2? This side is 2. Okay, what else do I know? I know that this side is 6. What is? Okay, so if these are both 2, then if this whole thing is 8, what's this? 6? Good. So then what's the area of this rectangle? How do you know that? Length times width is what? Area of a rectangle. So length times width. What about this one down here? What's the area of this one? Why? Good. The length is 8, the width is 3, so 24. So then what do I do to find the area of that whole shape? Add them up. That is the area addition postulate. So that fancy thing up there that says the area of a region is equal to the sum of the areas of its non-overlapping parts, all that means is to find the area of this whole thing. You cut it into pieces you can figure out, find the area of those, and then you add them together, which would give me what? 36. Okay, so this irregular hexagon has an area of 36. And what is area? Area is like all the inside stuff. So the way that I always describe it is, I think we've talked about this before, but the way that I always describe it is if you're making a garden and you build a fence, that's the perimeter. But if you cover the garden with dirt, that's the area, okay? If you fill the garden all the way to the top of the fence with water, what would that be? That would be the volume. Good. Okay, so volume is when you add a third dimension in. Okay, so you guys can see in a parallelogram right here that if you have this parallelogram, so the dark blue is the parallelogram, if you split it into parts, you could really turn this parallelogram into what shape? A triangle and a like shape right here. And if you move the triangle over here, what does it kind of become? It becomes a rectangle. So the area equation for a parallelogram is the same as the equation for a rectangle. Okay? It's just that we call it base and height. And where is the height? This is the kind of tricky part. So take a look at this parallelogram. Which one of those is the height? H. Why is it not 5? Bianca? Because it's diagonal, right? When you go to the doctor and they measure your height, what do they tell you to do? Stand up straight. Because what would happen if they took my height and I stood like this? I'd be smaller than I actually am, right? So I would be shorter than I actually was. Or if I stood on my tiptoe like this, it'd be taller than I actually was, right? So your height cannot be a diagonal line. So that means in this parallelogram, how would I find the height there? The what? When can we use the Pythagorean theorem? On that outside triangle. This makes a triangle right here, so we can use the Pythagorean theorem because this is a right triangle right here. What's the Pythagorean theorem? What's A, B, and C in this case? 5 has to be the C, so 5 squared. And then we'll make A 3. What's 3 squared?
9.
What's 5 squared? What's 25 minus 9? So what's B? 4. Okay, so B equals 4. So that means the height of this is 4. Now, way back when we started doing the Pythagorean theorem, and I said there's these things called Pythagorean triples, and they are common instances of things that always work in the Pythagorean theorem. 3, 4, 5 was a Pythagorean triple. And when you guys were like, I don't want to memorize Pythagorean triples, who even cares about Pythagorean triples? You don't have to care, except we could have saved ourselves 30 seconds of work, because you could have said, if this is 3 and this is 5, that has to be 4. So just think, like, whenever you think, I don't want to memorize something, it could save you time in the end. Now that I've talked about it so long, I've wasted even more time, though. So that's my plug for memorizing your Pythagorean triples. Okay, so if we have the height of a rectangle in which base is 5 and the area is this, how could we find that height? So what do we know here? The height of the rectangle, what else do we know? The base. So first things first, what do I always say to do? All right, so I'm going to draw a rectangle. The height is, I don't know, so that's h. And the base is 5. Actually, I'm going to make the height x, because that's the variable that's in my area. So what would I do here? 5 times x equals, how would I solve that? Yeah, probably. But let's simplify it as much as we can. So this gives me 5x, right? 5x squared minus 10. So what would I do there? Or minus 10x, because I moved this 5x over. So if I have 5x squared minus 10x, how would I factor that? How would I factor that? What could I factor out? I could factor out a 5 and x. So what would that give me? X minus 2. Good. Okay, so now I've got, those are my two factors. So let me move this down. So 0 equals 5x minus, x minus 2. So what could I plug into the 5x part to make it 0? 0. What could I plug into the x minus 2 part to make it 0? 2, because 2 minus 2 is 0. So my options are 0 or 2. So guys, remember, if factoring is like, oh my god, I don't know what that is at all, I don't remember that at all, that's the stuff that you need to come to office hours to go over, because that's stuff that you will need to know for Algebra 2. Okay, so what are my two options for what x could be? 0 or 2. But if it's actually a shape, then which one would it have to be? 2? Why? Can't have a measure of 0. Okay, so then it must be 2. All right, what about the perimeter of this rectangle in which the area is 12x feet squared? What's the height of that? 6. So if height is 6 and the base is what? X. Then 6 times x equals what? 12x. So then what do I do to figure out x? Minus 6x? So what just happened? X equals what? So does that make sense? So what do we do here? It's feet squared, so what does that mean? Do you think it matters? Yes? Why? That's the measure of what? Okay, what would I have to multiply 12x by to get, what would I have to multiply 6 by to get 12x? 2 what? 2x. So what's my base then have to be? No, my base is just what? Can you make it, can you simplify it? Can you get an answer for it? No, probably not. Do we care then? Do we need an actual number? No, not necessarily. We can leave it as a variable, but it says to find the perimeter. How would I find the perimeter then? 2x plus, and then 6 plus 6. What's 6 plus 6? And what's 2x plus 2x? So then we just end up with, can you add those together? Why not? Number and a variable. They're not like terms, right? Okay, so you don't always have to have an answer. It could just be something with a variable, and that's okay. All right, so if your base is 2x, that's fine. Your answer would just be a binomial then instead of just a number. It's all right if you don't have an actual answer. How do you find the area of a triangle?
Isn't it b times h times 1 over 2?
Yeah, why?
Because
Why is it b times h times 1 over 2 or base times height divided by 2? Why is area base times height divided by 2? What do you split in half? Yeah, why though?
because it equals
Okay, pretend that's straight. What shape is this? Sort of. Okay, so if this is base and this is height, how do I find the area of this? Base times height, length times width. All right, what happens if I cut it in half? Now I have a triangle. That's why it's base times height divided by 2, because essentially what you're doing whenever you find the area of a triangle is finding the area of the whole rectangle and then cutting it into how many pieces? 2, because there's 2 of them to make a rectangle. So the area of a triangle is 1/2 base times height, or base height divided by 2. All right, the area of a trapezoid, you take base 1 plus base 2, multiply that times the height, and then divide that by 2. Okay? These formulas, you will get all of these on any test and quiz that you have. Okay? So I don't want you to spend a ton of time memorizing the formulas. I just want you to be able to use them. Okay? I know it's hot in here, guys, but can you sit up?
oh my god.
Are you all right? Okay. All right, so how would I find the area of this trapezoid right here? The area of a trapezoid in which base 1 equals 9, base 2 equals 12, and height equals 3. Area would be 9 plus 12. So base 1 plus base 2 times what? 3 over 2. Okay, what's 9 plus 12? 21. 21 times 3 divided by 2. So 63 divided by 2, 31.5. Okay? You can leave it as a fraction. You can use a calculator, whatever. 31.5. So that's your area. Now, because it's got centimeters, what's our unit for area? Why is it centimeters squared? Okay, because you're multiplying centimeters times centimeters. Whenever you're doing an area, what shape are you talking about? How many dimensions does it have? It has 2 dimensions, so that's why you have a squared in your unit. So when we talk about volume, where we have length and width and height, then it's to the 3rd power because we have 3 dimensions. When we talk about length, it's just 1 centimeter. Like the length of a line is 9 centimeters. That's a 1-dimensional shape, so that's just centimeters to the 1st power. Okay, so that's where that comes from, because you're doing a 2-dimensional shape or a 3-dimensional shape. Okay, go do these 4 at your boards. Okay, so think back for a second. Rhombuses and kites. Let's just... Been waiting for that moment. All right, so with rhombuses and kites, remind me, these 2 things are called the what? These pieces that go across it, the lines that cut across it, diagonals. So when you see D1, D2, those are diagonals. All right, so when you're finding the area of a rhombus and the kites, we use the diagonals, not the sides. All right, does anybody have a guess on why we use the diagonals and not the sides? What do you mean by the sides can move?
Like they're not parallel.
Okay, they're not parallel to, there's not really even a relationship to each other, whereas the diagonals are what? Perpendicular, so they make right angles, they make right triangles, so it makes it a lot easier when we use the area to use diagonals, because it's like working with straight lines as opposed to diagonal curved lines. So just like we can't use a diagonal height, we can't use the diagonal side lines, so we use the straight lines that go across it. So D1, D2, all that refers to is diagonal 1, diagonal 2. Does it matter which one is 1 and 2? No. Okay, it does not matter which one you use as D1 or which one you use as D2. So the area of a kite or a rhombus, it's the same formula. It's just area equals 1/2 of D1 times D2. So you multiply the diagonals and then divide it by 2, or multiply it by 1/2. Okay? Multiplying by 1/2 and dividing by 2 are the same exact thing. So you could also write this as this. All right, those are the same thing. Okay, so how would I find D2 of a kite if D1 equals 16 and area equals 48? How would I do this?
Draw your kite first.
You could draw it. Yeah, you don't really need to draw this here because we already have these pieces, but I would recommend writing out your formula. So if the formula is area equals D1, D2 times 1/2, and I know that area is what? 48 equals 1/2 16 times D. So then what would I do next? 8D, why? Where did that come from? Good. So 48 equals 8D because half of 16 is 8. All right, and then how would you finish? So D must equal 6. Good. 6 what? CM. CM squared or just CM? Just CM. Why? It's the diagonal, not the area. Okay, how would you find the area of this rhombus? What's the formula? Okay, what's my D1? Okay, when you distribute, what is that going to look like? 60x squared. So you did that, and now you're doing this. Plus 40x plus 40. But we still have a what? Half. So then at the very end, what are we going to do? All right, half everything except what happens with these two? That becomes, all right, 100x. Mental math, guys. Next time we have a block, we're just going to do addition and multiplication facts. Okay, half of 60? 30 what? Okay, then what? 50x, because 60 plus 40 is 100. And then last but not least, okay. And that's it. Do we have to have an actual number answer? No. In fact, we can't get a number answer. Why not? Because our diagonals aren't numbers. And that's as simple as we can get it. All right? So that's it. That's as simple as your answer is. So there you go. When you distribute this, you have to do all 4 of the multiplication problems. So the first's the outside, the inside's the last. Some people call it FOIL. Do you ever learn FOIL? To multiply binomials? He hates it, so I'm not allowed to say it. It's the F word. We can't use it. I don't know. Because he wants you to just learn that you distribute it. So I just think it's a helpful reminder. So multiply the first ones, then the outside ones, then the inside ones, and the last ones. He doesn't like it because then if it's not binomials, people are like, I don't know what to do. I don't have an outside and a middle. If it's like 2 and 3. So it stands for first. So you multiply the first 2. Then the outside ones, so this one and this one. Then the inside ones, so this one and this one. And then the lasts. So FOIL.
Yeah, like I know it, but I
Yeah.
just say just
It doesn't matter. As long as you know to distribute it and you distribute it right. The mistake people make is that they just do the 6 and the 10 and the 4 and the 10. Yeah, so you got to do the middle ones. Okay? All right, so that's your answer for that one. So do these 2 at your boards, please. Okay, positivity.